Hello class. So we're starting chapter 10 section 2. Now that we've kind of gotten into the foundations of exponents, we're gonna talk about some properties. What happens when we're multiplying with different situations. And so there are a couple of cases. What I want you to do right now is I'd like you to complete the table here, which some of you may have already seen this. If you've already completed the table in your RPJs, then great, you can kind of move on and skip ahead in the video. Alright, let me do this first one here for you. The problem is 2 squared times 2 to the 4th. So here's 2 squared, 2 times 2, and then, so there's my 2 squared, and then times another 2 times 2 times 2 times 2. And so there's my 2 squared and 2 to the 4th power. And actually what you can do is, what you'll realize is you can get rid of these parentheses, and now your final answer would be 2 to the 6th power, or simplified, right? And so I want you to kind of go ahead and fill out the whole table, and hopefully what our goal is, we're trying to get rid of this step here and think of a shortcut from the first to the last. And that's what we're trying to do. Go ahead, take a minute to fill that out, and then after about a minute you can pause the video and then work on it on your paper, and then when you're ready to check your answers, unpause it, and then you'll see the answers shown up in a little bit. So if you finish the table, this is what you should have for each of the right side here. And again, I kind of want you to notice if there's a pattern, and maybe there's already something that you're kind of conjecturing in your mind. So why don't you scroll down to the next page. Now it says in here, describe the pattern in the table. So I want you to take a minute and see if you can kind of write down a pattern that you've noticed from the table. From the pattern, what it seems like, when we have the same base, we add the exponents, right? So when the bases are exactly the same for multiplication, then the exponents are being added. So if you look at this general rule right here, a to the m power times a to the nth power, my bases are the same, so that a doesn't change. Now I get a to the m plus n power. Okay? And then, so it says here, use your calculator to compare the powers from the third column with the products in the first column. So again, what we should notice is that they are being added. Okay, so that's one thing that you kind of have to memorize and remember that. So why don't you turn the page, and then we'll go through some examples. So the whole point of this property is so that we don't have to make this large table and do all this work and like splitting this thing into 2 times 2 times 2 times 2 and so forth. Instead, since we know that if they're the same base, that base stays the same, then we have the exponents being added together, 4 plus 5. And obviously 4 plus 5 is 2 to the 9th. So 2 to the 9th is actually the simplified version of 2 to the 4th times 2 to the 5th. So same thing here, if we have negative 5 times negative 5 to the 6th power. Now this actually has an invisible 1 power. So negative 5 to the 1. And so I have negative 5 to the 1 times negative 5 to the 6th power. And then when I use my property, I get negative 5 raised to the 1 plus 6. Again, make sure that the parentheses are around the negative 5. And then my final answer, once I add 1 plus 6, I get negative 5 all raised to the 7th power. X to the 3rd times x to the 7th. I just have x as my same base. and then I have the exponents being added together, and so x to the 10th is my final simplified answer expression. So I want you to go ahead and try these three on your own. Okay, pause the video, try them on your own on your paper, and then when you're ready to check your answers, unpause the video and we'll go through it. So here's the setup for all three. I'm not done simplifying each expression yet, but this is just a setup. So make sure you're on the same page there. If you're stuck, maybe you can ask a group mate. And then there's my final simplified expression. So this is what we have when we have two things being multiplied, but the bases are the same. That's the property that we're dealing with. If we go to the next page, we're going to be dealing with something a little bit different. If you notice here, this example 2, we don't have two bases. Remember before we had 3 to the 4th times 3 cubed, and then we added those two things, right? But now we have just one base, 3 to the 4th, raised to the 3rd power. And so the question is, what does that become? And so 3 to the 4th raised to the 3rd power means we're multiplying that 3 to the 4th 3 times. So it looks like this. So we have 3 to the 4th times 3 to the 4th times another 3 to the 4th. And so with what we just learned, since we have all the same bases, this becomes 3 raised to the 4 plus 4 plus 4, which is 12. Now, I'm going to show you even a better shortcut instead of having to do this step right here. W to the 5th power raised to the 4th power, you can actually multiply the exponents. So 5 times 4, so W raised to the 5 times 4 gives me W raised to the 20th power. Again, so this is a different situation when you don't have the same base, but you have something called the power of a power. Okay? So that's the shortcut for when you have an exponent raised to another exponent. So try on your own problems, numbers 1, 2, and 3. And again, pause the video. After about whenever you're done with these three problems, check your answers. So again, here's my setup for each problem. Again, it's not answered fully yet, but I just want to make sure that you're multiplying the exponents raised to the exponent. And there's my simplified expression. This is called the power of a power. The other thing on the first two pages, when you have the products where the bases are the same. The final example is finding a power of a product. So if you look here, inside this group I have two things, so a 2 and an x. And a 2 times x all raised to the 3rd power. This exponent kind of gets distributed. I put that in quotation marks just because it's not the technical term, but that's how a lot of students understand it. So meaning this cubed goes into the 2 and to the x. It goes into each base. And so we have 2 cubed times x cubed, and we know 2 cubed is the same thing as 8. And so our final simplified expression is 8x cubed. The next example here we have the group 3 times x times y all raised to the 2nd power. Again, we kind of take this 2nd power and distribute to all three of these bases here. And so we get 3 squared times x squared times y squared. We know 3 squared is 9. X squared we just leave it. Y squared we also leave it. So this is my final simplified version of that one. Okay, the last part that we want to do for our notes are these last 3 examples on your own. Again, try that on your own. Take about a minute, pause the video, and then work on it on your own. And after you're done, go ahead and check your answers. Again, here's just the setup for all 3. Just wanted to make sure that you distributed everything correctly, distributed that exponent correctly. And so our final simplified expressions are 625y to the fourth. Number 2 actually was already simplified, a to the fifth, b to the fifth, and then number 3, 0.25 m squared n squared. Now, if at any point you got lost in this video, just pause, rewind, go back to whichever example that you need to rewatch again, and then hopefully you and your group members can kind of talk about these 3 different situations. So we had 3 different situations. Situation number 1 was when you have the same base. Situation number 2 was when you have an exponent raised to another exponent. And then situation number 3 was when you have multiple bases and you can kind of distribute this exponent. If you understand everything, great. You're going to move on to the next activity. If you don't understand everything, go back to the video or talk to one of your group mates about what just happened and talk about the notes.